Okay, in this video, I'm going to show how to transform the function sinx and cosx. Here it shows the basic model of the transformations, and this is the sinx one, but it's the same as the cosx. It's got the four transformations here. A is the vertical stretch, compression, or reflection, and then C is the vertical shift, and those are both the vertical transformations. This one is moving from up or down. This one is obviously stretch, compression, or a reflection. If there's a negative, or positive is not a reflection, but negative is a reflection. And then K is the horizontal stretch, compression, or reflection. And then D is the horizontal shift, and those both are in brackets. So those are the horizontal transformations. Here we have the graph features. There's the amplitude, which is the distance from the midline to the max or the minimum. It doesn't really matter. Here's the formula to find it. It's A max minus minimum divided by 2, even though we're not using this today. K is 2 pi over period. The period is the horizontal distance in radians between consecutive like points, also known as one cycle. D is the phase shift, which is the same as the horizontal shift, and then the vertical displacement is the same as the vertical shift. Here are a model of the parent functions. This is sinx, and then this is cosx. As you can see, they're pretty much the exact same, except this one is shifted they're shifted pi over 2 apart from each other. This one starts at the maximum, and then this one starts at the rising midline. So these are their coordinates, and that's what we're going to be transforming. Here's the first example. First we have this one, which is transform this function right here. As you can see, there's a vertical stretch and a reflection. The stretch is by a factor of 2, and then there's a negative, so it's going to be reflected over the x-axis because it's vertical. Then there's the horizontal stretch by a factor of 2, and you can see here it says 1 over 2, but you do the reciprocal of that, so it's a stretch and not a compression. If it was 2, it would be a 1 over 2 compression. Then there's D, and this has a D right here, so it says take away minus pi over 3, but since we do the opposite for the ones in the brackets, here it says careful, make sure you switch it. It's adding pi over 3, which is shifting to the right because that's adding. Shift pi over 3 to the right, and then shift 4 units up. So here it says plus 4, and that's just exactly what it looks like. It's plus 4. So we're transforming this function. And this one's a sine function. So the rising midline is on the origin, and it's an odd function. So here I did all the transformations. So first is 2 times 0 plus pi over 3. Since it's 0, this is 0, and so it's just pi over 3. And then there's 2 times pi over 2. And then plus pi over 3 equals 4 pi over 3. And then you go on, just solve for each of them. And then I found how many notches it is to the right or left here. And the way that I got that was I just did, 1 over 3. I did 1 divided by 3, and then I timed it by 6 because this is 6 pieces of pi. And so here I put the dots, and we're just going to connect them because I already transformed them. You also have to do this with the y-axis, so it's negative 2 times 0, which is 0, and then plus 4. So that's for all of the zeros. I got 4. And then when you do it with positive 1, you get 2. And then for negative 1, you get 6. So here, you're going to connect the dots. There, and that's the transformed function. It's obviously been stretched because it's bigger than this one. Horizontal stretch, and then there's a vertical stretch. And you can see that there's a stretch because there's a farther distance between the maximum and the minimum. It's shifted to the right, as you can see, and it's also reflected. And then it's 4 units up from where it was before. Next, I have an example for cosine. Here is the cosine function, parent function. There's a vertical stretch here by factor of 3. There's no reflection. Horizontal compression, because there's a 4, you do the reciprocal, so it's 1 over 4. Horizontal compression by a factor of 1 over 4, and then shift pi over 6 units left. So here it says plus, and we know that we switch it because you got to do the opposite one, because the original formula already has a negative. So then you shift 1 unit down because it says minus 1. And so here is the parent cos function. And so here I transformed them. You just plug in the 0 and then the pi over 2, pi, 3 pi over 2. It's the same as what we did before. And then here I just found the how many notches you got to shift beforehand. And then here's 3y minus 1, so you just plug in the y and you solve. I got 2, -1, -4, and then the same one again. So here I put the dots. We're just going to put it on the graph. This one's compressed. So there, as you can see, it's been compressed a lot by a factor of 4, so that makes sense. It's been stretched a lot by a factor of 3, that makes sense. It's been moved to the left pi over 6, and it's been moved 1 unit down, which we can tell because the midline has been moved down 1. So there you go. There's transforming a cosine and a sine function and all the different components to it.